Welcome back to Geometry, Chapter 10, Section 7, the last section of Chapter 10. We got two more chapters after this. And we're going to be talking about locus, and the plural of locus is loci. Last time I told you, we'll talk about loci. That's fun to say. I always think of Francisco. That's fun to say. Okay. The word locus comes from location, not the bug that goes around and eats everything. Right now, all over the world, because it's 2020 and this is a crazy year, we have plagues of locusts all over the world. And I wasn't too alarmed, honestly, as long as they were over in the, across the Atlantic Ocean, I felt pretty safe. But now I've heard that they're in Argentina and Brazil. It's like, no, that's on our side of the world. Oh no. So anyway, we're not talking about the plague of locusts eating everything, the little bugs. We're talking about a geometry idea that comes from location. And the math book says one way people have described this is it's the path of an object moving in a plane. Well, our stuff doesn't move, does it? It just sort of lays there once we draw it. It's not like we're doing animated geometry. So a lot of times how I think of this is it's the union of shapes. What meets that criteria. So then I think of Dr. Doofenshmirtz with his Venn diagram, where he said, where you've got these things and those things, and where they intersect, that's the Venn diagram that, has to do with his evil plan with the innator that he is going to make. That he was always my favorite part of that show, not just because he wore a lab coat. All right, so here is an example. Draw and describe the locus of all points 3 inches from C. So that's what you would be given, and then you have to think, what would be a shape where all the points are 3 inches from C? I know, it'd be a circle. It's a circle with a center at C and a radius of 3. So they're kind of like puzzles. They're kind of like geometry puzzles. So here's another one. Points A and B are on a plane. What are the locus of points that are equidistances from A and B? Well, if you have a locus of points that are equidistances of A and B, we know that that's a perpendicular bisector from back when we learned about perpendicular bisectors. I know it doesn't look good, but just pretend. Okay, so I have and we know those two are equal, and then this makes a right angle. And then we are also told the other part of this that we're going to find the union of is that all these points are the distance AB from B. Well, if you have all points that are a certain distance from a point, you have a circle. So our other thing is this is the radius of our circle because the distance of all these points is AB. So now, oh, that's a terrible circle. Let's try to make it a little prettier. There we go. So what we have is a circle whose radius is AB, and B is the origin, and the locus of points that meet the criteria of all of this is just right there and right there. That's the union. That's the 2 points in all the world that meet this description of points. They have to be on a plane, check. They have to be equidistant from A and B, check. They have to be distance AB from B, check. There's 2 points that satisfy that. One of the places this is used in real life is for earthquakes. They put seismographs all over the world, but not necessarily on top of where an earthquake is going to happen. So here we have 3 seismographs in the center of each of these circles. And then there's an earthquake where the seismograph will get shook and have like shake marks, sort of like dropping a pebble into a pond, that go out in concentric circles. And the center of each one will be where the seismograph is. But then they compare their data, and where all of the circles intersect from the 3 seismographs, that's the epicenter where the center of the earthquake was. I used to teach with a teacher who she grew up in California, and she said they had earthquakes all the time and they loved it. And whenever it was an earthquake, she'd run upstairs to her attic because that's where the earthquake was the biggest, and hop in a rocking chair and let the earthquake rock her all over the place, which is not what you're supposed to do. You're supposed to go stand in a doorway. There's like a whole list of things you're supposed to do, and that's absolutely not what you're supposed to do. But she said she was too young and dumb, and she liked to play with earthquakes. Can't even imagine it. All right, come back for chapter 11, and we'll have a great time learning more. Geometry. Math is great.